Well, I want to warmly welcome everyone to the INE Cisco Certified Design Associate Bootcamp. We are thrilled to be bringing the Design Cisco track to all of our INE fans out there, and I am thrilled to see everyone in the live audience for this 5-day CCDA Bootcamp. My name is Anthony Sequeira. I am one of the full-time authors and instructors here at Network Expert, and I am absolutely thrilled to be presenting this 5-day CCDA Bootcamp event to you. We are going to have a lot of fun, and most importantly, we are going to have a sound education in the concepts that Cisco wants us to be aware of when it comes to designing intelligent networks. More on that a little later on here in the first lesson of Module 1. A little bit about me before we get started. I've been really thick in the IT space since 1994, where I experienced my first full-time job in the field here of IT with a little tiny company you might have heard of before called IBM. I was at the Tampa, Florida IBM facility here. And about 1999, I really started doing education full time with a company you might have heard of called KnowledgeNet. KnowledgeNet was purchased several times as it was a very exciting company that did, surprise, online IT training. And eventually, KnowledgeNet got gobbled up by a big company called Skillsoft. And I've got a bunch of friends over there still teaching for that company, Skillsoft, which is now KnowledgeNet, if you will. Also, you may have heard of my name with Cisco Press. I've been an author and editor with Cisco Press since 2001. And in 2006, I achieved the expert level Cisco certification of routing and switching. I'll get more CCIEs, I'm sure, as time allows, and I'm currently studying voice with the interest of eventually eyeing that voice CCIE. We'll see how that goes. But anyways, I am thrilled that all of you are here with me in this class, and it is going to be very interactive. Obviously, for those of you that are here in the actual live event, you will be able to chat in your questions at any time using the question and answer software in the virtual classroom. But for those of you that are attending one of the many variations of self-paced versions of this class, well, by all means, go ahead and post your CCDA questions on the support forums located on the IEOC.com. Also, you can post your questions on the INE blog, as we'll have more and more posts up on the INE blog related to the CCDA. So a couple of great places where you can post your questions outside of the actual live classes. By the way, for those of you that are in our live audience, you've got advantage of chatting with me directly, of course, but I want to remind you that if you are studying modules of this in the self-paced form outside of class, well, of course, you can take advantage of these great forums up on the internet as well. If you're wondering where this class fits in the overall scheme of things for our approach to certifying you at the expert level here at INE, it is definitely a Tier 1 class where we are going to learn the fundamentals about key technologies dealing with designing a robust Cisco network. By the way, you might think, oh, all right, well, this course is easy. You might think, gosh, well, this is Tier 1 fundamentals. Well, be careful. We will be talking about a lot of advanced, sophisticated technologies in here. So just because it's a Tier 1 class where we're going to build that foundation, I don't want you to make the mistake that we're not going to get rather intense in here in our discussions into some very advanced and sophisticated technologies. We build a strong foundation with our Tier 1 here at Network Expert, and then Tier 2 training, you really start focusing on applying particular technologies, and then in Tier 3, we would be testing you upon specific technologies. So here in Tier 1, we are going to fundamentally learn the principles of designing Cisco infrastructures. By the way, when it comes to testing you, though, we will do some testing of your knowledge. Each and every single one of the lessons of this course is going to end with some exam review. Sure, we love to do this exam review at the end of each of our lessons for a couple of reasons, really. Number one, we want to make sure that during the lesson you have mastered the particular technology to the level that the exam would expect you to have it mastered. That's really, really important. The other thing we do the exam review for at the end of every one of our lessons is to ensure that you have that you get a sense for the types of things you would be responsible for knowing about the exam. So it's kind of like a way for you to get in touch with the certification exam. A lot of times we'll do a lesson of content and students say, wow, that lesson was great. Wow, incredible. What a cool lesson. Awesome. But what in the world would the exam want me to know about that? Or how would questions be asked in the exam, or things of that nature? So that's another important reason we do exam review. And then I got to be honest with you. The third reason we do exam review is a lot of times it's a double check for me as your instructor to make sure that I covered key concepts with you fully. So it's a nice little double check for me to make sure that we have definitely covered all of the key features and technologies that I wanted to cover in a particular lesson. Well, we are going to cover an amazing amount of material over our 5-day CCDA bootcamp. I mean, we are going to look at the fundamentals of design and network models from Cisco, but then we're going to bury ourselves deep into the specifics of how to design a robust local area network, wide area network, how to design for addressing with IPv4 and IPv6, how you would go about selecting a routing protocol. And once you select the appropriate routing protocol, if it is EIGRP or OSPF or BGP, how you would go about designing properly for that particular protocol. We'll take a look at technologies like security and multicast and network management in this course, and we'll get a real feel for just how you would design robust infrastructures that incorporated those particular technologies. So the CCDA course, sure, it's a fundamental Tier 1 course from us here at INE, but as you can see from what we're going to cover, it is indeed very, very exciting, very robust as far as the topics we are going to teach you about. Now, the first module that we are going to present to you right now, no further ado, we are going to look at designing networks here in Module 1, and we're going to take a look at some acronyms that Cisco is really excited about lately, something called the IIN, okay, and SONA. We're going to take a look at what these acronyms are all about and why they're so exciting. And then we'll get into the nitty-gritty and start talking about, like, okay, how would we go about designing a network and what are key ingredients in the phases of network design. So the first module, we start with some great stuff right off the bat. Let's go ahead and get started. Let's talk about the overall goal for us when we're building a network. And you know what? Networks today, even our small office, home office, and you know what? That's the first acronym I'm really throwing out there to you. So let's make sure we master our acronyms in this course. Even the smallest of networks we might be setting up, our SOHO network, small office, home office, even these small office, home office environments, we want to build them intelligently, and we want them to feature intelligence to the end user. So a goal here of the overall course is for us to learn how to build the intelligent information network. The Intelligent Information Network. A network that just is not capable of moving around data packets from one point to the next, right? I mean, let's think about the evolution of networks for a minute. It used to be that we had what we called sneaker net. You remember the term sneaker net? I bet you some in the audience are so new to this subject that they don't remember hearing about sneaker net. Yeah, sneaker net is what we used to talk about before we had the data network. You would create maybe a spreadsheet in your DOS-based PC, and then you would put this spreadsheet on a floppy disk. That's right, a floppy disk. And back in those days, they were actually floppy. You could bend those things, a 5.5-inch floppy, and you would carry it over to your manager's desk, and you would hand him that spreadsheet on that floppy disk, and the manager would go ahead and put it in his PC, and then he would copy that to his system, and he would work with that spreadsheet. This was the sneaker net. Well, this was no network at all, right? This was personal computers working without robust connectivity to each other. Well, then the network actually became the network, and we started to network these devices together. But, of course, we were just interested in moving the traffic back and forth between the PCs, and the network didn't bring us anything. It didn't bring us any levels of intelligence beyond just being able to move the traffic from point to point. So networks weren't intelligent devices. Unfortunately, the networks were pretty dumb. They were just available for the transport of data between nodes on the network. The Intelligent Information Network is smart. It can do things like optimize various forms of traffic that we are using in the network today. And boy, there is so many various forms, right? Look at this. Oh, look at this cool PC that I've got depicted here. Notice we're going to be sending our voice traffic over the network. Notice there's a nice little internet camera mounted on the top of this PC. And notice we're doing some video conferencing on that PC. So notice there's all kinds of different forms of traffic that could be carried over the network now. And we want to build this intelligent information network, this really, really smart network that can properly optimize these various forms of traffic, that can add security for these various forms of traffic. And my goodness, if we have something like a power outage or some kind of network attack, we want to be able to make sure that that very important voice traffic is still able to be carried on the network. Think of how critical it is for us to communicate with voice over the network now. So the Intelligent Information Network is our ultimate goal in this class. But I'll tell you, as you might guess, it is a very, very complex thing to pull off. I mean, you don't just wave some kind of magic IT wand over your old stupid network and all of a sudden get this intelligent network. And I always remind my 8-year-old that I shouldn't say stupid, so I'll stop calling the old network stupid. That's rather rude of me. Let's just say the unintelligent network. You don't just wave a wand over that unintelligent network and suddenly achieve this IIN. So what we're going to do is, over the rest of this whole course, we're going to talk about pieces and models and approaches that we can take to building this intelligent information network. Why do we really need it, though? I mean, sure, we may be taking voice and video and putting them on the network, but why do we really need this network? Let's break that down. Well, it is certainly because of the growth in the overall scale and complexity of our applications these days. I mean, it used to be that we had like our office software, right? And that really was the software that was king on your network. In a Microsoft type world, it was Word, PowerPoint, Access, Excel. And these applications were fairly straightforward in how they worked, and they were the kings of the network. But now things have gotten a lot more complex with applications on a much bigger scale. Collaborative applications, like the one we're using right now, in order to do this virtual classroom and to educate people about Cisco design at the associate level, and to educate these people that are located all over the world today. Obviously, as our network applications get more complex like this and start operating on a bigger scale, we need the network to be able to adequately support these complex and these massive scale applications. You know, the network really has grown beyond just that basic connectivity that we spoke of before. And sure enough, video and voice applications on the network are a great, great way to exhibit that. I mean, network engineers just 15 years ago never could have envisioned the applications and the connectivity we would have today with voice and video. They were really just concerned mainly with that basic connectivity. Also, it's really funny as our CEOs like get on Facebook and they get on some of these remarkable social networking applications and they start doing Skype calls and all the rest. Our CEOs start saying, you know what? We should get a lot much more out of networks than we did before. So our CEOs turn around and they say to us as the IT guys, they say, you know what? Let's step it up here. I want to get more out of my investment in IT. I just went over to one of our competitors' websites and there was this like artificial intelligence, like customer service agent I spoke with. How come we don't have that? I just went over to Amazon.com and had a problem with my order, and all I had to do was input my phone number, and someone rang my phone back immediately from Amazon.com. How come we can't do that? And I just went up to Southwest Airlines, and I booked some airfare, and that e-commerce transaction was amazingly robust and simple. How come we can't do that? So more and more, our CEOs, and they're probably non-technical, by the way, our CEOs are wanting more and more from the network in order for the organization to meet its business goals. And that is going to be a recurring theme that we have in this class. You see, when we design robust Cisco networks, we are going after the business expectations of the organization. We're not just implementing technology because we can. We're not just implementing technology for the sake of, wow, the technology's out there and it's really cool. We're implementing technology to directly meet the business demands, the business goals, the business expectations of our organization head on, or the organization that we are consulting for. And sure, the bottom line for profit-based organizations is to make money, but understand that our goals for some new design in the network may be a bit more specific than just making money. For example, customer service. Maybe our organization is really taking a hit in the area of customer service, and we know that if we roll out the correct applications in the correct network infrastructure, okay, if we roll these out in the right way, we might be able to address this business need of improved customer service. We might be able to address it head on. So the goal of our intelligent information network obviously is to build more intelligence into the network. But what do we really mean by more intelligence into the network? I mean, what does that really, really mean? Well, we're going to see an increase in a key word here, integration. That's right. A key element for the intelligent information network is more integration than we have ever had before. We've got applications which integrate with something called middleware, and these applications also integrate with services, and all of this stuff is sitting on top of network devices like Cisco routers and Cisco switches and Cisco firewalls. And these applications and middleware and services, they all integrate nicely with the Cisco equipment. Now, wait a minute here. Wait a minute. What is this concept of middleware? I know that many out there in the audience right now are saying to themselves, what in the world is middleware? I obviously understand what an application is. That would be something like the Adobe Connect software we're using right now. And I understand what services are in the network. That might be something like quality of service could be looked at as a service. But what in the world is middleware? Well, let's cover that real quick with you. Middleware, if we look up the official definition, it's software that consists of a set of services. Okay, so it's more services here, but it allows multiple processes running on one or more machines to interact. So middleware is, it builds the interactivity between machines. You may have heard of some examples of middleware, like an object request broker. An object request broker would be an example of middleware, or SQL-oriented data access. That's a great one. So you have like these SQL servers that exist in your infrastructure, and you have these applications all over the place. And these applications that are all over the place in your infrastructure, they can gain access to the data that's in these SQL databases thanks to this middleware component called SQL-oriented data access. Wow, cool. So this middleware, think of it as like all of these little software objects that are like the glue. They're like the glue that allows this integration between the applications and the end users out there for key information that might be gained from another layer of the infrastructure. You might have a data center, and your SQL servers are tucked away in that high-performance data center. Well, applications need to be able to easily get in there at the data that's tucked away in that high-performance data center, and middleware are services that can make it happen. All right, so that's not just a term we want to throw out there. You know, a lot of times with these terms, you'll find people are, they're aware of the term and they use it, but they've never really stopped to think about exactly what something like middleware really is. So we got a lot of increased integration. That signals an intelligent information network. Also, the network is really great. It is really robust when it comes to allowing you to manage it. So an intelligent information network is very manageable. You can monitor the network. So an intelligent information network allows you to do robust monitoring of the network. Why is this so important? Well, it's so important because we want to be proactive. That is a big word in this course. We want to be proactive with our network instead of reactive. if there is some wide area network link that is getting more and more use lately, we want to be able to proactively detect that situation and potentially upgrade that key link before there are complaints, before there are service tickets in the environment. So we want to be very proactive about monitoring the network and proactive to what the monitoring reveals to us. Notice the opposite of proactive would be reactive. And this is not how we want to operate in our networks today. We want to cut down on the reactive nature of our networks, which means in our management of our networks, which means, well, we don't do anything until we start getting those help desk calls and those trouble tickets. Well, we don't want the trouble tickets to guide our management and operation of our network. Something else that the Intelligent Information Network does is it goes ahead and it optimizes. It optimizes the applications and the services that are running. So when we have a video teleconference, the video is seamless. It's just like watching television. And when we pick up the phone to do one of our fancy voice over IP phone calls, that sounds just like it always has when we've been using the public switch telephone network. So we want to make sure things run optimally. When someone goes up to the e-commerce portion of our website and someone makes a purchase from our e-commerce area, we want that transaction to go perfectly and totally smoothly and optimally. So that's another feature that the Intelligent Information Network brings. Something else that we can do with our Intelligent Information Network that is so cool is we can have the network itself enforce particular policies. This is so cool. This is so cool. We can have the network literally police itself. If you want to look at just from a security standpoint, and by enforcing policies, we may mean more than just security. But the example that immediately comes to mind here is for the concept of security. I mean, it is so powerful what the network can do, an intelligent information network can do. You may have a situation where you have this network, let's say we have a key router in the network, like this router 6 device, okay? And this router 6 device is going to engage in something inside the internal network. So here is our internal network. And inside the internal network, we have something called network access control. This can be done with Cisco with an appliance called the NAC appliance. Okay, so there is a box that Cisco sells that is awesome at giving us what we're about to talk about, this incredible network policy enforcement. So what can happen here is a device, we may allow some guest access onto portions of our network. All right, pretty cool. And this guest access might be permitted onto our network, but it has to pass the policies that are set up via the NAC appliance. Oh, okay. What kind of policies might exist? Well, perhaps the workstation that wants guest access onto this portion of our network, perhaps they have to be running WinXP. Perhaps they have to be running Service Pack 2 or higher. Perhaps they have to be running a list of improved antivirus applications, and they have to be including the latest updates. So absolutely amazing how the intelligent information network can take care of itself. Suddenly I'm thinking about like 2001 Space Odyssey here. Dave, what are you doing, Dave? All right, that was a terrible impression. But that's what it just suddenly popped into my head about this intelligent information network, right? Look at how remarkably powerful this intelligent information network is when it comes to taking care of itself. Yeah, okay, we will allow some guest access to some resources, but you have to pass all of these policy enforcement tests before you are allowed this guest access. So clever. So clever. And of course, clever is another word for intelligent, and that is what we can build in to our networks. Again, this isn't easy to do. This is not like it's something easy to do, this intelligent information network, and that's why we're going to be working through how we do it for a week-long boot camp here at Internetwork Expert. In fact, let's face it, the intelligent information network is so difficult to pull off. It is so difficult to pull off and implement. We are going to have to break it down into phases. Yeah, we're definitely going to have to break it down into phases. In the first phase of creating our intelligent information network, we'll just work on integrated transport. That's right. In your first phase of trying to achieve IIN, you'll just start thinking about, all right, let's try and get our voice properly on the network. Let's try and get our video onto the network. You're going to start to implement products from Cisco that fall under the Cisco Unified Communications Platform. The Cisco Unified Communications Platform is all about getting voice and video onto the network alongside of the traditional data that we have been putting out on the network for so very long. So we've got our data, and now we're going to add voice and video. This is starting to do our integrated transport. And this is certainly an important phase. By the way, I said data, which we've been doing for a long time, but please keep in mind that there is a lot of different forms of data now, right? So we do have a lot of different forms of data, unlike before where it may have been just, maybe web traffic and file transfer traffic. But now there is going to be a lot of different data that is going to need different treatment. So things have gotten a lot more complicated when it comes to data in our networks as well. Something else that we'll do in the next phase of IIN is we'll start looking at integrated services. Okay, so we'll start looking at integrating in these services into key areas like the data center. And this is where we might get really fancy virtualization services. So now we have like a lot of great redundancy in our network. We have these important voice servers running Cisco software for the management of the voice traffic, and they're set up virtualized. So if one were to fail, one takes the place of the one that failed completely and totally transparently with no loss of voice communications on the network. And then in the third and most high level of the phases of the intelligent information network, we work with integrated applications. And what is amazing about this is that you have this integration from the applications all the way down to the transport. This is called application-oriented networking by Cisco, or AON? AON, application-oriented networking. The network is application aware. It's optimizing, it's adding security as examples of services that the entire network is facilitating for your applications. This is just remarkable, isn't it? I mean, we think about how remarkable this is compared to the simplistic networks that we used to deal with, right? So there is this incredible integration on behalf of everything in the network. Here's how this might look like. We've got a PC. The PC plugs into a Cisco voice over IP telephone. That plugs into a layer 2 Cisco Catalyst switch. That plugs into a multi-layer switch. That plugs into a Cisco router. That plugs into an adaptive security appliance, a Cisco firewall. That plugs into another Cisco router. You get the idea. All of the Cisco devices start right here. This is, let's say, a Windows 7 box. But the Cisco technology, the network, starts right here with the voice over IP phone. And everything in this Cisco network is doing this application-aware network type approach. I mean, this phone is doing quality of service steps and security steps. And so is this layer 2 switch, and so is this multi-layer switch, and so is this router, and so is this ASA, and so is this router. Everything is aware of the quality of service and security measures that have to be provided for this very critical traffic form of voice over IP. So everything in the network is providing the integrated services that are required for this very complex voice application. Pretty exciting stuff. So exciting, I just dropped my pen. You may have heard that. All right, so three phases of the IIN approach, the Intelligent Information Network. We work on integrating our transport. We work on integrating our services. We work on integrating our applications. And we're getting close to achieving the Intelligent Information Network. But it's so complicated. It is so difficult that we need more guidance on how to do this from Cisco, and we need to break it up into a modular approach at achieving it. So that is why Cisco gives us the model called Cisco SONA. And when we return from a break, we'll go ahead and analyze this Cisco SONA. It's called the Service-Oriented Network Architecture, and it will guide us to achieving the Intelligent Information Network. So for our live audience here, we'll take a 10-minute break. When we return, we'll continue in this first lesson, and we'll take a look at Cisco's SONA as a stepping stone to achieving the Intelligent Information Network.